Hi everyone, and welcome to Toxiscandia, stories of a toxicologist living in Scandinavia. My name is Sveta, and this is the video where I'm going to tell you about the most harmful and the most dangerous chemicals that are a nightmare of every toxicologist. This is going to be the first part of this video where I'm going to tell you about the most important groups of chemicals that are scaring us toxicologists, and that is why I'm trying to bring also your attention to these types of chemicals in order to avoid them in your life if possible. And in the second part of this video I'm going to tell you about four more groups of these chemicals. So if you are interested in this topic and you don't want to miss the next video, you could subscribe to my channel. You could also push the notification button, then you will get a notification about the second part of the video. So stay tuned and let's talk about hazardous chemicals. All know that there is a massive amount of chemicals and different hazardous substances in our world. It would be nearly impossible to give you a full list of chemicals that are hazardous and dangerous to humans, and it would be also a very boring format. So in this video I grouped different types of hazardous chemicals according to their hazards and their properties. So we will start with the first group of chemicals that scare toxicologists. It is carcinogens and mutagens. You have probably all heard about carcinogens and mutagens, but it is important to know the difference, distinguish between these two groups of substances. Mutagens are substances that are able to cause mutations in our DNA. These are molecules that are capable of going into the cell and into the cell nucleus and then interact with our DNA, causing pathological changes in this DNA, damaging DNA. If this damage is not restored by our biological mechanisms in the cell, then it can become a mutation. But not all the mutations lead to cancer, because not all the parts of our DNA are equally important, and sometimes mutation goes unnoticed and nothing happens. But in unfortunate cases, mutations can actually lead to formation of cancer cell and to development of cancer. Good news is that mutations and damages in DNA are quite well repaired in our body. We have mechanisms that can do that, and mutations also occur naturally sometimes when the cell is multiplying and there are some mistakes or errors in the multiplication of DNA. So mutation can be a natural thing that needs to be repaired by our body. That is why we have all these mechanisms. But if there are a lot of hazardous substances around, some of them are mutagens, and if we are interacting with these substances on a daily basis, of course the probability of these mutations increases, and we are also risking development of cancer eventually. Carcinogens are often mutagens, but not always. Some carcinogens are not mutagens. So this is the relationship between these two groups of chemicals. If carcinogen is not a mutagen, it is usually too big a molecule that cannot actually go inside the cell or a cell nucleus. So it cannot directly interact with DNA. That is why it's not mutagenic itself. But it doesn't mean that the substance is not a carcinogen. A very well-known indirect mechanism of cancer development is inflammation. So if the substance causes chronic inflammation in our body, of course inflammation can be a good thing, especially if it's an acute inflammation. It can help us to defeat an infection. It activates immune system. But if inflammation becomes chronic, this process can become quite hazardous for our body, because during the inflammation so-called reactive oxygen species are formed, and these oxygen species are very actively reacting with all the cells and tissues around them. And if they get inside the cell and inside the nucleus, then of course interaction with DNA can happen, and then mutation can occur. So in this case, carcinogens are not mutagens themselves, but they are causing formation of reactive oxygen species that can be mutagenic in our bodies. So why are carcinogens and mutagens problematic? First reason is obvious, that consequences can be quite serious. If someone develops cancer, it is a very serious event. But there is also another reason, which is no threshold dose. Threshold is a very important topic, a very important concept in toxicology, and it means minimal dose when adverse effects occur. Usually, hazardous substances are handled very well by our body. Even if they get inside us, then our body has mechanisms to compensate for these effects of these substances. But this only happens below certain doses. So in these minimal doses, our body is capable of protecting us from the dangerous effects of substances, but if the dose becomes too high, it means that it exceeds the threshold dose of the substance, and then all the adverse effects can occur. And carcinogens and mutagens are substances that do not have any threshold, because even one molecule can lead to mutations and then development of cancer. So this non-existent threshold dose is a very huge problem when we are dealing with carcinogens and mutagens. So what can be done to handle the substances, to prevent them from causing serious consequences in human health? The first thing we can do is, of course, not to use these substances and avoid them in our daily life and in workplaces, in industry, for example, and also prevent them from getting into the environment, because we, of course, can get these substances indirectly from industry through the environment. So this would be the ideal scenario. Unfortunately, some substances are too important for us, for the functioning of society, for example, and then we have to use them. And in this case, if the substance is absolutely necessary to use, risks are assessed. And here we can talk about a so-called acceptable risk level. It doesn't mean that the risk is non-existent, it exists. And usually if the risk is 1 to 1 million, meaning that one person from 1 million people will get cancer because of this substance, then the risk is considered acceptable. Maybe it is a bit cynical, but in a perspective of functioning of the society, if some industry is really critical and really important, then we have to have this acceptable risk level, which is not ideal, but something that we have to accept. Some examples of carcinogens and mutagens. Acrylamide is one of the carcinogens that can be actually formed in our kitchen when we are frying something to the black color. Acrylamide is formed, and this is carcinogen. So we have to be really careful when preparing food, not to fry food too long for it not to become black or even dark brown. There are also carcinogens that are formed during fuel combustion. These are, for instance, polycyclic aromatic hydrocarbons. Metal ions can be carcinogenic. One of the examples of good carcinogens or good mutagens is chemotherapy, which is actually mutagenic to cancer cells. And this is the purpose of this therapy, to kill these cancer cells by damaging their DNA. So here we cannot actually stop using these substances because they are too important for us. The second group of substances that is scaring toxicologists and should be also scary to people is endocrine disruptors. Endocrine disruptors are all the substances that affect our hormonal system. This can happen by different mechanisms. For instance, when substance is mimicking natural hormones in our body and interacting with our receptors that are used for natural hormones. So here the substance comes and interacts with the receptor instead of natural hormone. It can also inhibit these receptors or inhibit natural hormones that we have in our bodies. Problematic thing here is also a threshold. Technically, these substances can have threshold dose, but usually we don't know what it is, because hormonal system is very well tuned and very small doses of hormones are needed to trigger different processes in our body. So although technically threshold dose might exist, we are dealing with endocrine disruptors as if it doesn't exist in reality. Examples of endocrine disruptors is very well known Bisphenol A, which is used in plastic products, and in many countries it is actually banned for children plastic products, for example milk bottles, because endocrine disruptors are very harmful for organisms during their development. If we are adults and we deal with endocrine disrupting chemicals, of course we can be harmed, but not as bad as the organism that is being developed as a fetus or as a child that still has their brain developed during the first years of life. So in these cases, consequences can be actually much more serious and much more dramatic. This is the reason why Bisphenol A was banned from plastic products for children. Another example is phthalates, also found in plastic and also in some cosmetic products, and fortunately also banned in many countries. Another example is pesticides. Often when they are left on food, we are unfortunately exposed to pesticides, and they can also have endocrine disrupting properties. Number 3 is reprotoxicants. Reprotoxicants are a bit related to endocrine disruptors, but they specifically affect reproductive system of humans. Reprotoxicants can affect both female and male fertility and also can affect developing organism, fetus. As I already said, there are some sensitive windows of development in history of human life. Of course, it's a fetal phase when a child is in the womb, and then when a child is born, their brain still develops during first years of life. So these are very sensitive windows when the effects of endocrine disruptors or reprotoxicants can be very serious, very dramatic, and often irreversible. Examples of reprotoxicants are heavy metals such as lead, mercury, arsenic, and cadmium. Lead was often used in old paints, and this is how children might have got exposed to lead. Mercury is heavy metal often found in fish, especially in large fish such as shark. So the larger the fish, the more the probability of getting mercury from it. Heavy metals also formed in industry, and cadmium is something that smoking people get from cigarettes. And pesticides are also reprotoxicants often, and it is not that much of a problem if we get it from the food, but when someone is working on the farm and working with pesticides, one has to be really careful with protective equipment, because pesticides that end up in the body through inhalation are the most dangerous ones, and they can cause the most dramatic effects in the body. And fourth group for today is neurotoxicants that affect nervous system. Here we can talk about acute poisoning, where the large dose of neurotoxicants is used, or a person is exposed to a large dose of neurotoxicants. And here, of course, the effects can be very serious. Damage can be so serious that it can be even lethal. And there is also chronic poisoning. That is also dangerous for us because it goes slowly and often is not noticed. And here also sensitive windows of development are very important. Neurotoxicants can be very dangerous for fetuses and also for kids that have their brain still developing. Examples of neurotoxicants are also heavy metals such as lead or mercury, and there are stories that this old paint that contains lead was often eaten by children, these flakes of paint, because it had a sweet taste. So this is quite dangerous, sounds really bad for me. There are also pesticides that are neurotoxic, such as organophosphates, for example. This can result in slower development and lower IQ in kids. And there has been a perfect example of this, where two populations of genetically similar people were living on two sides of a mountain, and on the one side of the mountain there was a pesticide fabric, so only one population was affected by that. And if we compare pictures of 4-year-old kids from both villages, it will be a dramatic difference in these pictures, although we don't expect a 4-year-old kid to be Picasso, but still there are some standards how a kid of this age should draw. And here in the pictures that I'm showing you, you see this difference. And this is really shocking, at least for me. I hope you are also very impressed in a negative way with this, which shows that pesticides can be really harmful for us, especially for those who are in sensitive windows of their development. So these were the 4 groups of the most dangerous, harmful chemicals that are a nightmare for toxicologists, and 4 more is coming next week. So thank you for watching. I wish you a really nice day. Stay strong and healthy. If you like this video, please push the like button, and don't forget to subscribe to my channel, and see you next time. Bye bye.